Alrighty, so as many people probably can come to understand, plants don't really need any food source to survive. They kind of just do their own thing. But you always hear that they need to have sunlight and water. Like if you have plants outside at your home, you go and water them every day. Well, the way that these plants can function and grow and keep doing what they're doing is through a process a lot of people probably also know, which is photosynthesis. Photosynthesis is just a process in which plants can obtain energy from sunlight and water. It's plain and simple as that, as it can sound. It actually breaks down into a much harder, longer, complicated process that I feel more people should know. That way they understand how plants actually grow and how they help us. So photosynthesis can be seen as a combination of two different processes that kind of culminate in like the massive amount of energy that they're able to have. Because I mean, to grow and function doesn't take just little amounts, it takes tremendous amounts of energy. I mean, we eat several times on a daily basis just for our growth. So only imagine each individual plant, grass, anything in the world that needs that sort of process to continue going. So this first begins in like the leaves of the plants, which are the more photosynthetic cells, which are the mesophyll cells. These contain chloroplasts, which are a little tiny like organelle inside of the thylakoids within them, which are another sort of like little organelle, but it's a little bigger than the chloroplasts. These beginning reactions for it, as I said, there were two parts. These are called the light reactions. And so back to within the thylakoids themselves, they contain these pigments that help absorb the light. Those pigments, typically the most prominent ones are chlorophyll A and chlorophyll B. But this chlorophyll A is the main one because it's a strong oxidizer. To oxidize means it pulls electrons away very easily. And the electrons that it's going to mainly be pulling away is those electrons from water that we had talked about before. These stealing of electrons then ends up causing a lot of protons, which are the little things that are opposite of electrons, to be drawn in towards the thylakoid, because that's where all the electrons from the water are going towards. So that's going to end up creating something called a protein gradient, which is just basically a massive amount of protons. So having that will eventually cause more electrons to become attracted to it, resulting in more and more of the molecules to be broken away from water molecules or other things that the plant can end up using to create its energy. So this beginning of the light reactions is also considered to be non-cyclic, as it doesn't really repeat itself very often. It's got to undergo specific things to do that, which for a plant just aren't very rare. And the process only creates two ATP molecules. That just means basically energy. There's no other way around it. But these two molecules aren't enough for the plant to keep going. It needs a lot more than just two. So what happens is that there's a separate process, the second part of this, called dark reactions. And these occur with molecules called NADP+. The plus is because it's got the protons on it more. The H pluses is what they're usually referred to as. And by having this positive charge, it creates a drawing from the excited electrons from before, from like taking them off of water, excess in this case now. And then they go into a thing called a photosystem, which is kind of a major part in which the process takes place. It's what can draw in even more sunlight because of the pigments of chlorophyll it has within it. It has increased amounts. But transitioning into the photosystem itself honestly causes a problem for the molecules, believe it or not. Even though it's a whole process, it creates problems in it before it can actually resolve them. And the problem in this case is that all of those NADP molecules that they have only can create one ATP. And if there's only 18 per se for the 18 ATP needed, and then we end up needing 12, and we can only get 12 NADP, then we're going to be short by 6. So the thing that causes these to run out is that the reuse from the electron source from the plants at their disposal run the process over and over and over again, which is what causes these dark reactions to be considered cyclic rather than non-cyclic, because they're happening constantly. But following the dark reactions, they also undergo towards the later half of their reaction, they undergo 3 different processes, each called carbon fixation, carbon reduction, and carbon regeneration. In the first of these, carbon fixation, there's enzymes inside of the plant's cells that they use to grab even more electrons and add it to other chains of carbon within their cells and organelles and organs and all that sort of thing. And that's what the plant needs. The plant always needs CO2. That's why you always hear when you breathe out, it helps the trees or helps the plants. That's because we exhale CO2 while they basically exhale O2. And that creates such a great relationship with our furthering of life, basically, between humans and plants, because of our like switching that we do in order to survive, at least in terms of like how we breathe and how they are able to create their food source. And so the second part, carbon reduction, is exactly how they get that food source. It takes protons from the CO2 molecules that they had and puts it on other ones, so it kind of leaves one short, one overpowered basically. But that overpowered one is what they more need. That's what creates a sugar called G3P. That G3P is what is the end result that we wanted to achieve. That's what their food source is, to continue all the processes from before that we were talking about in order to create these massive amounts of ATP, which at the end of this process, they end up getting about 36, which is 18 times the previous 2 that we had. So finally, the final thing in the whole process of photosynthesis would be carbon regeneration. So in carbon regeneration, it basically just prepares for a final G3P sugar to be created over and over and over again in the process, because they're cyclic processes. So with all that being said, I wanted to really talk about that because, I mean, like I said before, a lot of us have heard that there's great relationship between trees and humans because of what they do for each other. And clearly through my explanation, it's very obvious that this relationship is strong and is there. And without one another, we have no clue what we could be doing otherwise.